Now we're back in Tinkercad to show an application of a latched circuit. What I have here is a decimal to BCD to 7-segment display circuit. So over here I have a keypad that's going to represent my decimal digits 1 through 10, or actually 1 through 0. Down here I created a combinational logic circuit that is actually doing the encoding for me. So it's going to encode decimal to BCD. This is my BCD display here. So these 4 LEDs are going to display my binary coded decimal. That is going to output to my 7-segment decoder. And that 7-segment decoder actually has a built-in latch right here on this pin. This latched pin is active low, just like a RS flip-flop or a D flip-flop is. Not a D, I'm sorry, just an RS. And it will latch the information to this 7-segment display. To build the encoder side of that circuit, I had to build a truth table first for me to sort out how I needed to connect my OR gates together in order to accomplish that logic. On the left-hand side here of the table, you can see I have each of my decimal digits 0 through 9, and then I've mapped those decimal digits to the binary coded decimal place values over here on the right hand side of the chart. And I've labeled each place value with a letter here, D, C, B, and A, to correspond with the 1s, 2s, 4s, and 8s columns. And then I went through and made a Boolean logic statement for each of the place values. As a result, I end up getting A is D1 or D3 or D5 or D7 or D9. And with B and C and D, I get those same OR statements there. So now I can use OR logic gates strung together to make these statements true. And that's all I really did over here in this circuit. Each one of these decimal place values is wired to the right series of OR gates, so that when I simulate this now and press button 1, my 1 place value lights up. I press 2, my 2 place value lights up, and so on. There's a 6, 4, and 2, right? You notice that when I let these buttons go, my output disappears. But the output remains latched in my 7-segment display over here. That's because the output from my combinational logic circuit is being displayed here and then sent to my 7-segment display, which is then latching that information when there is a high signal here. So right now, these diodes right now are blocking any current from coming this way through my switches. So my inverter is making this pin read high and setting my latch to a high signal. When I press my button, it puts a high signal on my inverter. The inverter puts its output low, which turns this pin low and allows me to reset all of the input that's coming in from my circuit. So I have to press this button. It turns the latch off when I press the button. It sends the signal through my encoder to encode the BCD. The BCD comes into the 7-segment display with the latch off. It sends that output to my display, and then it remains latched once I let go of the button, because this signal will then go back to high and hold that information in place. With this specific circuit, I didn't put any debouncing on these buttons here. So sometimes I can actually get some strange things to pop out of here, output that I really don't expect, because the debouncing will give the circuit here enough time to fully transpose my information through. It seems like it's working okay right now, but every now and then I'll get sort of a strange wonky result if I don't hold the button down long enough, or if I have a little bit of a problem. See that I'm trying to make it happen, but it doesn't want to happen right now. Nope. So far it's working the way it's supposed to. But just let it be known that every now and then I can press this button for a 1, 2, 3, 4, 5, and I'll get something strange like a 0 or a 4 or a weird number. That's because these buttons aren't actually debounced and sending faulty information through my circuit.